and be alert. So let's move to the further discussion. I hope last session we done about array function, right? Next we need to go for what? Another function we need to go for it. I hope you followed the documentation, right? So next function we need to go for it. Next function we need to go for it. So yesterday you are there in the online, right? Sanjeev Rai, your name. Okay, yesterday your question was solved. Okay, good. So now we must go for next discussion. What is the next function? Second function is a range function. Okay, this also I will increase the font. So go to that. Now try to see that a range function we need to go for it. A range function. Yeah. What is the use of this function? Let us look into that. So there we are supposed to understand the syntax first. Very easy, mom. This is not at all difficult. Pandas and NumPy is not difficult for us because we have seen many of the topics in Python. Okay. Now variable name is equal to NumPy dot a range of the begin comma end comma step. Begin comma end comma step. What is the meaning of begin comma end comma step? Begin comma end comma step. It is as good as similar to a range function. What is the range function will do, guys? Start comma stop comma step. Here also you can write start comma stop comma step, no problem. Variables, what is there? Nothing is there. Start comma stop comma step. So step, three things are there here. Start comma stop comma step. So what is the a range function will do? It generates the elements from start to stop minus 1, stop minus 1 with what value? With the step value. With the step value. Okay, it with equal interval of value. Similarly, I want to generate, yes mom. So start comma stop comma what? Stop comma step value. So what it will do? It generates, come on fast, it generates range of values. It generates range of values from where? From start to stop minus 1, stop minus 1 with what? Equal interval of value. Equal interval of value. Equal interval of value called what? Step. Equal interval of value called step. For example, I want to generate something like this. So here, okay, this is called what? Step. Start comma stop comma step. Go to the Python environment here. I'll say import NumPy as NP. NumPy as NP. Okay. Now I need to go for what? A is equal to, already we discussed, a range of I can say 10. What is this meaning of 10? It generates from 0 to 10 minus 1. I just said only one value. Actually, three values, three syntaxes are available for us. Three syntaxes are Python or Java. So 10. What is that meaning? Only one syntax I am writing. Here, combined together, I wrote everything. Combined together, I wrote everything. NP dot a range of 10. What is happening? You print of A. Print of A. Type of what? A. What is the topic is going on? Are you remembering first? What is the topic is going on? How to create an object of ND array. Number of approaches to create an object of ND array. We are discussing. So see that it is going to create 0 to 9. And what is that object name? ND array. So a range function always creates one-dimensional array only like this. It can't create two-dimensional array. Three-dimensional array we cannot create. But we need to go for reshaping that. We need to reshape it. Okay. So how do you print the dimensions yesterday? I shown you some attributes yesterday. Did you remember that? What is that, ma? A dot ndim A dot endim, that is called a one dimensional. A dot shape, A dot shape, it will give you only the number of elements. Number of elements are what? 10 elements, 0 to 9, 10 comma, number of elements. Now, A dot D type, A dot D type, D type will give you the, is what? Int 32, int 32, int 64, float 32, these are all called what? C language data types. Not a difficult at all. Now I need to go for this elements are there. Now I want to reshape it in a matrix format. A range function cannot give the elements in the matrix format. Yesterday, array function can give the elements in the yesterday's class 0D, 0 dimension, 1 dimension, 2 dimension, and 3 dimension. So here I would like to go for placing, reshaping it. How do you go for it? Yesterday's class, I just formally shown you. There is a function called what? Reshape function. Reshape function present in where? ND array. ND array. Reshape function present. 1 minute. I will take my presenter. I'll take my once that point I will take it. So once I'll take that. So coming to the point of it, you come here. So now I will take this. Reshape is the function present in where? ND array. What is this ND array is called? Class. That class contains a function called what? Reshape, and pass your ND array object. So here, how I will call it? NP dot. That is called, I will say, what is that object now here? What is that object now? A dot. A dot. What is that ND array object now? A dot. Reshape of, pass the shape of it. What is that? 3 elements are, 9 elements are there. What is the possibility of the matrix can be formed? 3 by 3. Am I correct? 3 by 3 only you can form it. 3 comma 3 I am saying. 3 comma 3 I am saying. See that it is going to print. Okay. So I will pass it. I'll pass it something like this. What is that? Okay. So how many? Okay, fine. Correct. 0 to 9 means what? 10 elements totally, right or not? 3 by 3, if I say what is going to be happening, problem or not? Totally how many elements, ma? 10. 3 by 3 means how many? 9. 3 by 3 means 9. So 10 elements are there, you cannot arrange into 9. What about the rest of the element? Problem or not? Yes, sir. Now you can arrange it 2 ways. Yes, Rocky, Senapati, correct. 5 comma 2 you can arrange it. 2 comma 5 you can arrange it. 2 comma 5 you can arrange it. So it is going to be suitable for this 10. Okay. Let us go to that. A dot. Okay, same thing. 5 comma 2. 5 comma 2 you say. 5 comma 2 you say. Shape of it. So it is going to give you what? 5 rows. First one is called what, ma? Rows. And second one is columns. One more I can say 2 comma what? One more way I can rearrange it. Are you getting this? 2 rows and this one. So how do you reshape a matrix? By using which function? Reshape. So here a range function can give you what? A list of elements which is starting from stop to stop, and this is called one syntax at dimensions, and I can rearrange it. One more type of element I want. A is equal to np dot, come on, little I'm speed up the things now. A range of, I want to say take some 12 elements. From where I will take 10 comma 22 I will take it. 22 I will take it. 22 I will take it. So here it is going to print of A. It is taking an array of how many elements? 10 to 21. Totally how many elements, ma? 22 minus 10. It is going to be how many? 12. 12. To find out whether it is 12 or not, len of A you take it. 12. Okay. Now how do you do that? Print of, already I said again and again, don't get into picture of that concept. Don't forget that. Okay. So coming to the point of it, A dot ending, next A dot what? Shape. Now you are going to get these 12 elements. Now I want to rearrange these elements. How do you rearrange the elements quickly? Come on, quickly. Go to that once again. I will rebuild it. Print A. print A, len of A dot endim. Next I'm going to say what? Shape also, A dot shape. These are all called attributes. Reshaping the matrix now. Come on, B is equal to first reshaping A dot reshape of, come on, 3 comma 4. First one, B print it, BU print it. See that this is printed. About the B properties, you print it once again. B dot, come on, ndim. What is that? 2 dimensions, 2 rows and then rows and columns. How many rows? 3 rows. And columns are how many? Right. That is dimensions means rows and columns is called 2. Yesterday I said you how to decide the dimension. Suppose if I want to locate this 11, how do you locate it? 0th column and then first column. 0th column A of indexing. So easy for you. 0th column and next is what? First column. 0, 1, 2, 0, 1, 2, 3. This intersection point is called what? 11. So one index, another index. How many dimensions are there? 2 dimensions are there. That's why. Next is called what? Shape. I will write it. Shape. I will write it. What is the shape? 3 comma 4. Okay. Next I will go for one more kind of approach. 4 comma 3 I can take it. 4 comma 3 I can take it. So it is going to be C here. I am saying C here. Print of what? C. C is going to be called what? 4 rows and 3 columns. I can reshape it. This is called which dimension? 2 dimension. That is rows and columns. Same thing I want to go for what? 3D. Can I go to 3D? What is this first one? What is this dimension? First 1 dimension. What is this dimension? 2 dimensions. What is this dimension is called? 2 dimensions. Rows and columns. Here shape is called only one shape. Here it is shape is called 3 comma 4. Now I want to reshape it to what? 3 dimension. Come on. C is equal to, come on, plan it out. The number of elements are 12. Come on, don't take much time. I can write it. 3 comma 2 comma 2, 2 comma 2, one thing. And next is called what? 2 comma 3 comma 2, 3 comma 2. Next is called 2 comma 2 comma 3, 2 comma 3. Any of the possibilities you can take, students. Like that you just go for factors of this 12 will become the dimensions of your matrix. Shall I? Let's go to this place. I'm going to say C is equal to something like what is that? A dot reshape of 3 comma 2 comma 2. Okay. So I will take it equal to like this. Print this C. See that 3 matrices. Each matrix contains what? 2 rows and 2 columns. 2 rows and 2 columns. Did you understand? Are you getting? Next is called one more way. One more way I want. What is the one? D is equal to. So 2 I will write it. I'll say 3 comma 2 I can say. Print this D. 2 things, 2 slabs. That is called 2 matrices with what? 3 rows and then what? 2 columns. Now say that D dot ndim, 3 dot ndim, D dot 3. Next is called what? D dot, what is this now? Shape is going to give you something like this. So I hope A range function, I hope you are understanding it. Right? And next, if you want these elements to be coming in your own data type, look at that. I say here, D type is equal to float. I am saying D type is equal to float. Invalid keyword or something. Okay. So I'm writing here, D type is equal to, I'm saying shape is equal to, I say, comma, D type is equal to float. So takes only one argument. Okay. It takes only one argument. Well, so no problem. So I'll take it. Fine. Only one argument it will take, reshape is taking. During that conversion, you will take that kind of thing. Which time you can take it? Which time you can take it? During this discussion, you can take it. Let me build that object once again. I'll go for this, comma. What is this now? D type is equal to float, you say here. D type is equal to float, comma. Next parameter is comma. So here, print A. What is that? Dot, 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 it is saying. So like that, you can go for it. You can reshape it. C is equal to A dot reshape of 2 comma 3, 2 comma 3, 2 comma 3. Say that C, it is going to be all floating point slabs are created. This is the first slab matrix. This is a second slab matrix. This is called a multi-dimensional matrix, we can call. Able to understand? So if I go to the documentation part, what I just shown you in the last session, ND object creation, array function already completed. Now I am going for A range function. One more example I want to show you. Look at A is equal to NP dot A range function of 10 comma 10 comma something like 34 comma 2. I am saying 34 minus 10 is how many? 24. 24 each time is what? 2. It is going to be how many? How many will come? 12 elements will come. So it is going to be called what? Like this. So LN of A, you can decide how many elements are going to come. 12. So 2 elements will come. You can rearrange that. You can rearrange it to 2D. A is equal to, or B is equal to, I can say reshape of something like 6 comma 2 B. You can arrange the same elements into 3D also. So that you understand that. Go to this place and see that. A range function I will show. The array function yesterday's class I explained. A range function I am going to show. A range function. ND array object name is equal to numpy dot A range of begin comma end comma step comma D type. So this function is used for generating one-dimensional array of values, but we can't create a two-dimensional array. To convert a one-dimensional array of values of ND array object into two-dimensional array, we use what function? Reshape function we use. Two-dimensional and 3. 2D and 3D. 2D and 3D, guys. In general, any two-dimensional and n-dimensional array, we use which function? Reshape. See that of 9. So 0 to 8. I am going to print. And what is the dimension? 1. What is the shape here? 9. What is the D type? 32 by default. I am reshaping it into 3 into 3 because I used only 9. So 9 elements will be reshaped. Whatever examples are there, same thing I just already have it. I am showing that. And B you printed, this is the data. And this is printing at a time. Dimension I am printing. Shape I am printing. D type I am printing. So dimension is 2 dimensions, rows and columns, whose shape is called 3 comma 3. Total elements are int of it. If you look at A is equal to NP dot A range of just 9. You print A 0 to 9. That 0 to 8 is 9. A dot reshape of it. B is equal to A dot reshape of, I am saying what? 3 comma 3 because 9. B you print it. That complete thing I am going to say. What is that? B dot ND comma B dot shape, comma B dot what type? D type. It is going to print what happens. So comma here. So comma need to give. So the data is getting printed. Dimension is 2, shape, and then 32. That is what is here printed. And the next is called what? It is called what? Range. So syntactically I am starting with this. Second start comma stop value. So printed here what? This many values. How dimension is 2? What is this, Ganesh Verma? Yesterday I told you, Nama. Again you are asking. Rows and columns. Rows and columns. How many dimensions? 2. Explain this rows and columns. You understand or not? Dimension. Simple. So 0 2. This is called 0 2. 10 2. 22 minus 1 is 21. Printing the data, this elements, and the dimension is called 1 because it's only like array looking like 12 elements are there totally. I am reshaping it into 4 comma 3. Print the B, printing like this. Reshape of 3 comma 4, it is reshaped again into this way, and I am printing B dot ending. It is a 2. This because rows and columns are there. B dot shape is called what? 4 comma 3. So related to D also, 2 comma 6, 2 rows and 6 columns. Reshaping of 6 comma 2, print that E value. A dot reshape of 12 comma 1, all 12 complete thing is this one. Are able to understand? So this is comes under what? This is comes under A range. Understand? Yes. Amma? Who said? Lelian function is a general function. Ln function is a general function. Everywhere else, Ln function is there. Which function? Which function? Which function, ma? Not like that. Which function is not available in NumPy? Just to tell him. Which function? Say little bigger. Say, I need to know your doubt now. So, okay, you write in a paper. If whatever you are having, you write in a paper, you show them, they will understand, they will tell to me. Or you write in a paper, you show me, I will explain. Okay, na? So don't have any fear, okay? You ask me, no problem. But I should understand, na? Your doubt I should understand. Right. So, length. Len, na? Len. Arrange. A range. Okay. Range we cannot use. His doubt is, instead of A range function, can we use range function? So you see that already you can apply that now. So A np dot something like A is equal to np dot range of 10 comma something like 16 comma 2. So it is giving an error. You can read module NumPy has no attribute range. Did you mean that means instead of range function, they did not carry range? Why they did not carry? This was already there in the traditional Python. So they did not take that. They took it as range with what? Array. Right? Simple. So small things you express freely. A range function is there, not range function is available. Yeah, Ganesh, you are not getting more dimension, you are not getting a. So I'm not getting dimensions, you are saying. Ganesh. So how Ganesh? So you are not getting that thing means. So I have to explain to you. Okay. I'll try last and final because range is dimension is important. Come on to the point. A. What is the type of A? Ganesh. Only Ganesh will answer my questions. What is the type of A? Only Ganesh should answer my question quickly. If you make it late, I will move forward. Int. Okay. Print of what? A comma type of A. Type of A. How I am retrieving that A? Directly I am writing it. Directly I am writing it. Can I convert it into ND array? Can I convert into ND array? Quickly. B is equal to, you forget that. NP dot array of what? A. Converted. Yesterday only I said this. Print B. What is there? Only one element. How I printed? Directly I can say print B. No need to use any index or nothing. No need to use any dimension. To print the dimension, I am writing B dot ndim. B dot ndim. No dimensions at all. That is called 0. Now I am writing Ganesh. Your doubt came now. No dimensions at all. Now I am saying shape. Is it having any shape? Shape means 2 elements, 3 rows, 4 rows, 3 columns. No such rows and columns. That is nothing but empty. Empty. Understand? What is the D type here? D type. D type. It is going to contain what? It is going to B dot what? D type. It is going to give you what? Int 32. Int 32. So his doubt is dimension, no dimension at all, because I am writing directly B value is printed. What is the need of writing B of 0 and all? Eliminated, 0 dimension. Next I am going for A is equal to NP dot array of 10, NP dot array of 10 comma 20 comma 30 comma 40. This is my what? List. Print A array of elements. It is just looking like what? Normal list of elements converted into 10 dimensional. So what is that now? A dot ndim. How many? To access this, first of all, dimension easily it is 0th index, first index, second index, third index. How do I access this 10? A of 0. This is called what? I am writing only one index. On the basis of index accessing, dimension will be created. Dimension will be decided. How many indexes I am using to locate the values? Only one. So what is the dimension? One dimension. One dimension. See that? One dimension. Understand? Fine. Now, same thing if I take it, 10, 20, I am taking, careful students, 10, 20, it is one list. Another one is like this. Another one is like this. What is that now? Inner list I am taking. You print A. You print A. See, Ganesh Verma made me to repeat. Yesterday I was repeated. Once again I am repeating. 10, 20, 30, 40, 30, 40. See that carefully. 0, 1, 0, 1. Now this is called a A. Same thing I was explained yesterday. How do I access this 10? A of 0, if I say only 0, I will get this entire thing, I will get it. But my intention is not to get that. My intention is to get the 10 completely. So it is an intersection of what? Two things. So it is called like this. How many dimensions I am using? How many indexes I am using? 1 plus 1. It is called what? 2 dimensions. 2 dimensions I am using. To access this 40, I am writing here A of what? 1 and then 1 I am using, which is known as what? 1 dimension plus another dimension. It is called what? A 2 dimension it is called. So I am going to say here A dot ndim. It is going to be called as what? 2 dimension. Understand? Simple. Next, I am going to take up. Next one is same thing, same to same. Yesterday's class I said, again I am going to say the same thing. It is 10, 20, 10, 20 like this. This is called a one thing. I am writing. One more thing I am going to write it. 50, 50. I am writing 50, 60, comma, 70, 70, 80. I said this one. This is also called one more matrix or not? One more inner list. What happens? So, coming to this point, check it out once more. This entire thing will be one thing. This everything to be kept into another place. Yeah, I forget one open bracket. Yes. Now you print. How many slabs are there? This is one matrix. This is another matrix. 2 matrices are there. This is one matrix. This is another matrix. Yesterday I wrote the diagram also. So here, this is called one matrix. This is called one matrix. This is one matrix. My matrix is called what, you know. Yesterday I wrote this diagram, and 10, 20, and this is called 30, and this is 40. And behind of that one more matrix is there. This is called a diagrammatic representation for three-dimensional matrix. This is called what, you know, 50, 60, 70, 80. And this is the diagram which I am taking here. So here this is connected. Here this is connected. Okay. So I hope diagram I wrote little bit. Okay. Don't worry about it. This is called what? Zeroth matrix. This is called what? First matrix. Zeroth matrix and what? First matrix. Are you getting me? So next is called what? This is the 0 and 1, 0, 1. What is this now? 0, 1, 0, 1. This is minus 1. This is called what? Minus 2. And still you want in negative directions. This is what you know, minus 1. This is minus 2. This is minus 1. This is minus 2. This is minus 1. This is minus 2. And this is called minus 1. This is called minus 2. Already you know negative directions as well as positive directions, which is already well aware of it in our classes. Now, how do you access this matrix? First matrix, how do you access it? A of 0, if I say, which matrix will come? Which matrix will come? This will come. A of 1, if I write it, which matrix will come? Second matrix will come. In the first matrix, I want to 20, I want to get it. How do I get it? A of 0 matrix. 20 is available in the 0th matrix. And whose rows and column? Whose rows and column index? 1. Come on, sorry. This is 0, ma. Sorry. 0 and what? 1. 0 and 1. By mistake, I wrote it. 0 and 1. 0 and next is what? 1. 0. 0th row. What is this 20 column? 1. This will be how many dimensions? How many indexes? 3. That is called 3. 3 things are going to come. What is that 3 indicates? Dimension. How many indexes I am using to locate an element? 3 I am using it. So this is known as which type of dimension? Which type of dimension? So, yes, ma. Yeah. Come on, 0 this is called. 0. A of 0th row and then first one. This is going to give the element called what? 20. That is called which dimension? 3 dimension, you will get it. I hope you are understanding. Ganesh Verma, if it is clear for you, I hope you are understanding. A dot, what is this now? Ndim, 2 dots I am using. A dot ndim, and A dot shape also you can say it is going to give you 2 matrices with 2 rows and 2 columns. That's it. So this is about, yes, Rocky, very good. Ganesh, are you okay? Ganesh, are you comfortable? So, okay. So next I'm going for one more type of function. What is the next function I'm going for? Zeros function I'm going to introduce. Once we understand one function, other thing is going to be easy. Okay. What is the use of array? It converts any type of object of traditional Python objects into end array object. A range function will do what? Generate some range of values by following begin, end, step kind of thing. I can reshape it to any of the matrix. Next, a 0 function is there. You see, zeros function means it is going to build a 0 matrix. Even in our mathematics, we are coming across 0 matrix. See, np dot zeros of, I'm writing something like, 6 I'm writing. 6 meaning is 6 elements will be coming with all zeros. The name itself says zeros. How many? 6 zeros will come. and that is an object of ND array once again. Just to see that first variety of syntax, print of A comma type of A, type of A. What is this now? By default, it is taking float. Float. What is this now? ND array. Whenever I need any type of zero related matrix, when I want to write any zero matrix like this, some zero matrix I want to write it. 0, 0, 0, 0, 0, 0, one matrix I want like this. So I will go for generating this matrix by using what? I of 0, 9, 9, I will reshape it. I will reshape it. So I got 6 elements. 6 elements means what? No, mom. I will convert it. By default, they designed like that. You want any int type? Rocky. D type is equal to what? Int. You see, A you print it. A you print it. Type of A comma D type 0, 0, 0. So you got it. Are you able to get it? Yes. So, coming to the point of it, zeros here. Ganesh Verma, 2-dimension matrix. But 3-dimensional matrix is also there. Not only 2-dimension, 3-dimensional matrix is also there. Take care. There is a little extra part of that. So now I am getting how many elements? 6. Now I am going to say A dot reshape of what is the possibility of a reshape of 6 elements means what is the possibility? 3 comma 2, 3 comma 2. See that 3 comma 2. Next is called what? 2 comma 3, 2 comma 3. This is called one type of possibility. What is this now? 6 elements are generating whatever the matrix you want like this. Now I want to get it. 9 elements I want. 9 elements I am taking. Say A dot reshape of 3 comma 3. I'll be getting something like this. 3 by 3. You can print it. You can print it. You reshape elements. You print it in this B is equal to B. You print it. What is the dimension? B dot endim and B dot shape. You are going to get 3 comma 3. End dimension is called 2. I hope you are understanding about this discussion. Next, this is called one variety of thing. Now I am going to write it. Directly I can say, see this students, I can say, here I am writing, shape is equal to, I can write, you need not write shape, I am writing, something like, 4 comma 3, 4 comma 3. D type is equal to int. Just observe it. I am passing in the tuple format. Right? Int I am taking. So I am going to get the 0 matrix of which size? 4 comma 3. So see that A, it is going to get it into what? 4 rows and 3 columns. Here I got it what? Here you got it what? Only 9 elements I got it. Here you see, I said 6 beginning. 6 elements I got it. 1 dimension I got it. If you want, you can specify what? 2-dimensional 0 matrix also you can build like this. What is the dimension here? A dot endim. Here every moment I am trying to tell you 0 dimension, 1 dimension, 2 dimension, 3 dimension. Other than that, nothing is there, guys. Don't feel difficulty. Here I am writing what? Straightforward. Say 12. Say 12. A dot endim you write it. It is called what? 1. What is there? This I am going to say. Next one is called like this. Next one is called like this. 4 comma 3. I got it A. Yes. This I want to convert it into what? Multi-dimension also. How do you do that? B is equal to A dot, come on, reshape of, what is this now? 2 comma 3 comma 2. 2 comma 3 comma 2. Are you following? How do you do this now? Say that B you take it. Like that I got it. Like that I got it. C is equal to, I am saying. C is equal to, I am saying something like, 3 comma 2 comma 2 I am saying. 3 comma 3. C is equal to, you see how many matrices are coming? 3 matrices are coming with what? 0th matrix, first matrix, second matrix. -1, -2, -3. These are also going to be like this. So how many matrices here? What is the dimension here? Come on. C dot endim, 3-dimension. Senapati, 3-dimension. Is it very big doubt? Dimension easily understandable or not? N dimension 3. What is the next? C dot what? Shape. What is the shape here? 3 matrices. Each one is called what? 2 rows and 2 columns. Are you able to get it? Three matrices. Each one is containing what? 2 rows and 2 columns. Simple. How do you access this matrix? How do I access this? 0th matrix, first matrix, second matrix. All of them are same only. C of what? 1. C of 1. C of 2. C of 0. All of them are same thing like that only. Very easy. Nothing is difficult. Come on to the next point of it. Next I'm going to say one more thing here. I can write it. You can write in this way also. Here I can write shape is equal to keyword arguments, our basics of functions. D type is equal to, I can say like this. A, I can print it like this. That element, I can reshape it whatever I like it. So coming to the function called what? Zeros function. What is the zeros function is? This function is used for building zero matrix or creating an ND array object with zeros with a specifying its shape. What is the syntax? ND array object is equal to NP array dot zeros of shape comma D type. D type. Easy, not a difficult at all. Yes, Mabramani. Shape can be either 1 dimension or 2 dimension or what also? 3 dimension also. 3-dimensional also. I will show you 3-dimensional also to you. 3-dimensional also I will show you. 3-dimensional, let me show you. Yes, ma, Rocky. I want to, yes, sir. You can, that is very easy. I have a matrix. That's what I'm saying. In Python, we are learning the operations. When you learn data science, there you may use different algorithms. There you will use this type of operations. B of something like this, just for example. A plus some matrix I need to use it, which is supposed to be A itself. Definitely which matrix I require here? Zero matrix required or not? So I want one matrix which is added with something I want with the same matrix. I keep on adding the matrices value to further matrices. First I need to take this matrix and a zero matrix. Second matrix C, D matrix. I go on keeping on adding the matrices. At the fundamental stages, I said you. S is equal to 0. If you remember our Python, for val is equal to for v in LST, I told S is equal to S plus 0, S plus V. We go on repeating this, something like that. I go on accumulating the sum of the matrices. So I will take what matrix? One zero matrix, I can take it. So this NumPy, we are just giving as an additional knowledge for you to enter into the further data science level. If you go for it, there may be useful this type of operations. That's why we are getting the knowledge on NumPy. Fine. Next, reshape is equal to, I'm going to say what here? 4, 3. Or I will say 3, 3. What is the meaning of it? Can you understand? Shape is equal to 4, 3, 3. How many matrices? 4 matrices. Each matrix is containing 3 rows and very good. Say print A. See that 4 matrices with what? 3 rows and 3 columns. Is it possible to build with a traditional list? If I write a list, you have to struggle a lot to remember that braces. But it is going to be a complex things also can be done very, very easily. I hope you are understanding this mechanism. Okay. So coming back to this area, next 1-dimensional, 2-dimensional, I can go for 3-dimensional. And here specifying D type is optional. By default, what is an output is coming when I don't specify the D type? floating point values will come. Right. This is about which matrix? Zero matrix. Same, there is a matrix called a ones matrix is there. It is for addition purpose we use it. For multiplicative, cumulative multiplication or accumulative multiplication you want, go for what matrix? Ones matrix we use it. What is that matrix name? Ones. This is which matrix? Zeros matrix. For example, ones matrix I want to use it. I will say that also. I hope you are understanding this matrix called what? Next go. NP dot ones. The name itself says ones. How many? 6. Just keep it. First syntax. Only shape I am saying. 6 means one dimensional. A you print it. How many ones are coming? 6 ones. Filled with 6 ones. You say here I am writing D type is equal to what? Int you say. It is going to print A. It is going to build like this. How do you reshape it? A dot reshape of 3 comma 2. 3 comma 2. You say 2 comma 3. 2 comma 3. Done like this. Are you following? It is purely building what matrix? Ones matrix it is printing. The function itself says that ones matrix. It is building the ones matrix. If you want, you can build like this also. How do you build? So I'm saying that 3 comma 3 I am saying. 3 comma 3 I am saying. See, you must pass in the tuple ma. You should not write like this. Don't write 3 comma 3 like that. You have to write it is a shape. 3 comma 3. D type is equal to int. Say this A. 3 comma 3. 3 comma 3. I will say, yes, Brahmani. 2 comma 3 comma 3. 2 comma 3 comma 4 you want. 3 comma 4 you want. See that A. See that how many getting? 2 matrices with 3 rows and 4 columns. Which matrix I am taking? Ones matrix. Zeros matrix. Zeros matrix. Right. Compulsory these kind of things are used in the data analysis part or complex mathematical analysis. You may come across in the data science once you implement almost all the algorithms. That's why NumPy is providing this many big calculation part. Easy manner. So coming back to this. So zeros function. You understand the syntax? Shape comma D type. It can be 1 dimensional, 2 dimensional or 3 dimensional. Here specifying D type is optional. And examples of zeros 6. 6 zeros are coming. Reshaping to that. Reshaping to 2 and 3. Reshaping to that. 12 comma D type of int. 12 zeros are coming. Reshaping into 3 comma 4. Reshaping into 4 comma 3. Printing that B. Printing that C. Type of A. Type of B. Type of C. All of the reshaped matrices are ND array, ND array, ND array. Now I am going to see the second syntax. Zeros of what? Shape I am writing directly in the tuple format. NP dot, this I am saying 3 comma 3. This is not necessary. I can take off because it is taking float. Of shape of 3 comma 3, D type is equal to int. 3 by 3 matrix is coming with zeros. NP dot zeros of shape of 2, 3. D type is equal to int. So it is going to give you A and how many? 2 rows and 3 columns. Zeros we are getting. NP dot zeros of 4 comma 2. Int type. 4 rows and 3 columns. Easiest part. Right? Their address is means address of this A. Definitely ID will be there or not. Yesterday only we shown you. There, Ganesh Verma. Address will be there for A. Address will be there for A. Coming to next, which function? Ones. What is the purpose of ones function? Same to same. Same to same. This function is used for building a matrix with what? Ones. Or creating an ND array object. Initialized with all ones. Ones. Syntax. ND array object is equal to NP dot ones of shape comma D type. What is that now? Start with N is equal to NP dot ones of 6. So printed 1, 1, 1, 1. NumPy dot ND array. Printed dim is called what? One dimension. Shape is called six elements, and D type is called by default float. And reshaping of six elements 3 comma 2, I got it. Reshaping of 2 comma 3, I got it. Now next, A is equal to np dot ones of 8. D type is equal to int. I got it. Print A type and all. So printed ND array object. And I'm saying reshape of that 4 comma 2. 8 elements means 4 comma 2. I got it. np dot ones of 3 comma 4. D type is equal to int. A printed 3 comma 4. Next, A dot reshape of 4 comma 3. I got like this. Now I'm going for 2-dimension reshaping. I'm going for multi-dimensional ones of 2 comma 3 comma 4. D type is equal to int. 2 matrices with 3 rows and 4 columns. Similarly, 3 matrices with 3 rows and 4 columns. 3 matrices with 3 rows and 4 columns, all of them. With A dot endim, which is called 3. And the shape is called what? 3 matrices with 3 comma 4. Did you understand this? Are you okay? So once it is going to be zeros and ones are going to be something like this. And the next you will expect, sir, is there any twos function to filled with twos? Is there any function to filled with this? So not like that. Twos, threes, fours functions are not there, but there is a function called what? Fill. Full. There is a function called what? Full, which is going to take shape it is going to take, and it is going to take fill underscore value, and the next is called a D type. This is the function we are having, which is present in which module? NumPy module as well, which is going to fill with the value which you are specifying. Suppose I want to fill a 2 by 2 matrix. 2 by 2 matrix you want to fill. There is a commenting line I wrote for your clarity. A is equal to np dot, full of which matrix you want to fill? Three I want to fill. I want to build a matrix with 3s. Full of 3 values. Zeros you filled, ones you fill. Now I want to print 2s I want. Now you need to say shape. Shape you need to specify. What is the shape I am specifying? 3 comma 3. 3 comma 3. Now you are saying called what? 2 you are saying, for example. What is coming? 3 comma 3 comma 2 means what? Print A. So it is filled with what? 2. What is the dimension? 3 comma 3. So it is going to fill with 2. What is the fill value here? 2. This one. What is the order of the matrix? 3 by 3. I want to fill the element. I want to fill the element 9. 9. So I am going to say A. It is going to fill with what? Completely 9. Are you able to get it? Now you may say something like this. Now you may say something like 3 comma 2, something like this. Print A. What it is going to be? 3 2's will come. 3 2's will come. What is this now? A dot endim. A dot endim 1. Now please, previous one you see, this one you see, A dot endim 2 dimensions it will come. Are you able to follow? Next you see 3 comma 3 comma 3 comma 3 9. What is this now? 3 matrices with a 3 by 3 order. What is the value you are filling? 8 I will use, for example. 8. Print A. What is this now? A dot what? Endim. It is going to be A dot shape. A dot shape. Are you following? What is the full function will do? What is the full function will do? Last and final. A is equal to np dot full. Np dot full of np dot full. Shape is equal to 2 comma 3. I say 3 comma 2 comma 3 or 2 comma 2, whatever you like it, comma fill underscore value is equal to I say what? 5 comma what is this next? D type is equal to what? Int. D type is equal to int. Are you able to follow? So what is this complete meaning? Print A. It is going to print like this. Next, you can say here I am writing fill value. I am writing here I am writing shape is equal to I am saying 2 comma some 3 comma 2 I'm just saying like this. A, it is going to be, what is this mechanism? Keyword arguments. I know 3 parameters, but I don't know the order. I can pass any one of the way. So functions concept only available. What is the use of full function? I can build whatever the function I want with full of the specified value. Zeros function will fill 0. The ones function will fill 1, and a full function will fill any value. If I want to fill value 5 is filled. If I want to fill 0, you can fill 0th element only. So full function is an advanced format of what? Zeros and ones. Clear? And this A also type of A. And if I see also ND array object only. So these are all called ways and means to create an object of ND array. We are just initializing the values here. Did you understand? Very simple. How many functions are there? Come on. Number 1, array. Next, A range. Next, zeros, ones, full. Next, I am going for I function. Shall we go for I function? This is very, very important. I function I will show you. I. Okay, before that I would like to show you the documentation part also. Once function, full function also I will show you. Full. There is a syntax. Full, NP full, shape, fill value, D type. I am saying that this function is used for generating a matrix by specifying user choice value or building an object of ND array with our value. Building an ND array object. So here, fill value is called what? Programmer defined value. Fill value is equal to what? Programmer defined value. Examples you see on the part of this example. A is equal to np dot full of 3 comma 4. D type is equal to what? Int. So it is going to fill with what values? 3, 4 I want. 3 elements of which value? 4. 3 elements of 4. Which type it is? ND array. Are you getting? Next you tell me full of 12 comma 6. What is the meaning of it? 12 of 6. Come on. 12 elements of which one? 6. It is called one dimensional purely. I am reshaping it to what? 4 comma 3. A dot reshape of 3 comma 4. Array of like this. Next is called what? NP dot full of 4 comma 5 comma 8. What is the meaning of it? 4 comma 5 with 8. 4 rows, 5 columns with a value called 8. This one. Full of what? 3 dimension. 3 matrices. 2 by 2 with what value? 8. See that. This is the one. Are you following? Next, I am going to talk about the I function. What is this? ND array object is equal to np dot I. It is, try to keep a special eye on this. ND n comma m is equal to none. M is equal to none. K is equal to 0. D type. This is a syntax. What is n? What is m? What is k? What is a D type? Actually, I function is used to generate identity matrix. Identity matrix, you know, principal diagonal elements are 1. Other elements are called zeros. Are you understanding this? Fine. Coming to the next step. Actually, identity matrix is always a square matrix. But here, it is one of the advanced form of identity matrix. Like full function is an advanced form of what? Zeros and ones. Like I function is an advanced form of identity function. There is one more function called identity function. So just let me go for it slowly. I will introduce A is equal to np dot I. np dot I am writing n represent rows, m represent columns. I say 3. That's it. 3. I say that's it. Only 3 I will say. I did not specify what? M. I did not specify what? K. I did not specify what? D type. Are you able to follow? I did not specify M. I did not specify K. I did not specify D. I am specifying only what? Rows. Listen, whenever you specify the rows, that is called this one, automatically n value will be taken for what also? M. If I don't specify the m value, n value will become m automatically. That will build which type of matrix? 3 by 3, 3 by 3 identity matrix will be built. 3 by 3 identity matrix will be built. What is that? 0, 0, 0, 0, 0, 0 will be built. 0, 0, 0 will be built. What is this now? A. Carefully follow. 0, 1, 2. 0, 1, 2. This is called what? 0, 1, 2. You know this kind of thing. And my dear students, I am not writing 0, 1 at this stage. Of course, this is called 0 matrix. What is our matrix of I matrix says? It is going to say which matrix? 1 minute. I matrix says the same thing. If you take it, identity matrix I set. 1, 1 minute. 1, 0, 0, 0, 1, 0, 0, 0, 1 it will take. What is this now? I matrix says 3 by 3 matrix is specified. You know students, K is there now. K is always pointing to the principal diagonal. K is always pointing to the principal diagonal. K is equal to 0. Please keep in mind. Principal diagonal is called what? 0. Below the principal diagonal is called what? -1. That below principal diagonal is called -2. Are you getting? Above principal diagonal is called 1. This is called what? 2. K is equal to 0 means what here? Make the principal diagonal elements as what? Ones. And below 1 and above 1, below principal diagonal, above principal diagonal is becoming what? Zeros. K is equal to 0 means principal diagonal elements make as 1. And n value is called 3, which is becoming which value? M value. And K is by default what? 0. That means principal diagonal elements are called what? 1. And print this. A you print it. What is this now? 1 point, 0 point, etc. Now, what is the D type I am mentioning? I will say D type. I'll say D type. Comma. D type is equal to what? Int. Now I am saying A. 1, 0, 0, 0, 1, 0, 0, 0, 1. 0, 0, 1. Yes, Rocky. What is this 3? I am specifying what? N. M I did not specify. What is actually N? Rows. M is what? Columns. Identity matrix meaning is what? Square matrix it is. Square means what? Rows and columns are same. If N is 3, if N value is specified, automatically N value becomes what also? M value. K is equal to 0. K is equal to 0 means which elements are 1? Principal diagonal elements are 0. This is called K is equal to 0. You can make below principal diagonal elements also 1 by specifying the K value as what? -1. You can make the below principal diagonal elements as what? 1 by writing this. You can make above principal diagonal elements also once. That is by, this is 1. K value. This also you can make it as this. This is called 2. So K is equal to 0 says what? Principal diagonal elements. K is equal to -1 means what? Below principal diagonals below principal diagonals. K is equal to 1 says what? Above principal diagonals. I hope you are understanding. Are you able to understand? Above principal diagonal this is. By default, what is the K value? 0. Minus 1, minus 2 says what? Below. K is equal to 1 and it says what? Above principal diagonal. I'll go to more and more. I'll go to more and more. Don't worry. I'll say here, I'll say something like 8 I will take. 8. See that such a big matrix I generated. What is the principal diagonal? Come on, guys. This is called what? K is 0. I don't want that now. I want to make these elements. I want to make these elements. This element, this red line elements, I want ones. Once. I want once. What you will do? This is called what? Minus 1. If I make it, K is equal to minus 1, that will become. Can I make it? Go. Once I will make it. Go to that. K is equal to what I am doing? Minus 1, comma, D type. See that now print A. What is happening? What is happening? Carefully observe it. Carefully observe it. This is going to become 1. The other thing is called what? K is a parameter. K is a parameter. Formal parameter. Already we discussed or not? That one I am using as what here? Keyword argument. Keyword argument. See below principal diagonal changed or not? Minus 1. Are you getting? What is this next? Minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. I'm going to write K is equal to 0 by default. Ganesh Verma, I told already. This is called what I am writing? Minus 7 I am writing. Minus 7. A is equal to, you see, last one become 1 or not? Above principal diagonal, this part I want to make it. Above principal diagonal, what is the K value please? 1. A value is 1. Now make it what here? K is equal to what? 1. You need not write this. Why I am writing K is equal to 1 here? Because I am not specifying M na. That's why I need to write keyword arguments. See that. 1. A is equal to, you see, A is equal to this one. 1, 2, 3, 4, 5, 6, 7. So 7 you want. 7 you want. See the 7. I say A is equal to. See that last one is called what? 7. If you write other than that 8, if you say 8, what will happen? 8. Completely zeros only. Completely zeros. What ma Rocky? I want before also K is equal to 0 and K is equal to 0 also 1, sir. That you need to generate 2 matrices ma. Not possible in the single matrix. Because you are executing 1 matrix at a time or not? 1 matrix at a time. 1 matrix at a time. If you want that facility, we will take it 0 and we will take 1 matrix. A comma B is equal to this. I will take it. This is called one thing, comma. I can say this one also. I can write it. K is equal to 1 also. I can write it. So this is K is equal to 0. Need not to write. Need not to write. A you print it. B you print it. You got the same answer like this. In one matrix, both of them are not possible. Rocky, did you understand, student? I got it, both of them. Multi-line assignment. If you apply your intelligence now, you can get any solution. Are you getting? Okay. This is called what? 8 into 8 square matrix. Now I am going to introduce what? Tell me, did you understand the meaning of K? What is the K? It represents diagonals. Diagonals. What is the default diagonal? 0. Below 0, minus 1, minus 2. Above? Yes. Now I am going to say, slowly coming to this place. I am seeing that 3 comma 4 comma, okay, that's it. D type is equal to int. What is the meaning of the 3? Please rebuild once. Syntax I will rebuild. I will show you the syntax. Yeah, go. Now I will take 3 comma 4 comma D type is equal to int. What is 3 ma? N. What is 3? N. What is 4? Earlier M value was what? None. Earlier I was specified only single 8 only. 8 is common for n and m. Now it is going to be specifying different. How many elements will come actually? Come on, ma, please. How many elements? 3 rows, 4 columns. 12 will come. But our I matrix always meant for what? Building identity matrix. Identity matrix always what? Square matrix. But 12 is not a square matrix, na? What is the possibility of square matrix out of 12? 12 elements are there. 12 is nothing but rectangular matrix. But identity matrix always square. In 12, what is the possibility of square matrix near to it? 3 by 3. 3 by 3 is a square matrix. But 4 by 4 is not a square matrix. 4 by 4 is 16. But I have how many elements? Only 12. 9 elements are square. That too, you see, 3 means what? 0, 1, 2, 0, 1, 2, 3. Out of that, I need to prepare which matrix? Identity matrix. What is that? 3. This portion only will become what? Identity. This portion will become what? Non-identity. Means, okay. I'll get it once again. Get it, look into that. Actually, this is all called some small mathematics background. 0, 1, 2, 0, 1, 2, 0, 1, 2, 3. Because I mentioned 3, 4. 1, 0, 0. First you build that out of 12 elements, you build the 0 matrix. 0, 0, 0, 1. Remaining elements are there, na? Remaining elements are there, na? Filled with what? 0. This is called what? Meaning of 3, 4. How many are sitting there? 4 members are there. Let it be. Right. Very good. Come on. 3 members. Let it be. It is also one extra service. Because it's a new trends, all these things. New trends. Fine. Ajay. Ajay, switch off your video. Switch off your video, man. No problem. Listen carefully. No problem. Listen carefully. Right. Okay. Okay, no problem. Okay, ma'am. Come on. Fine. Are you understanding this 3, 4? Out of 12 elements, 3 by 3 elements is becoming what? Identity matrix. The rest of them are called what? Zeros. Now next, I hope you are understanding. Print that same environment you see. See that this part is called what? This part is called what? Other elements are what? Zeros. Now I will take. Be careful. I am going to take one more. 4, 3 I am writing. 4, 3. What is happening that time? What is happening? First you recognize. What is that? It is going to be how many? 4 rows. First you plan it out. 0, 1, 2, 3. How many? 0, 1, and then 2. What are the values? From this I need to prepare what? Equivalent closer to this 3 by 3 matrix. 4 by 4 I cannot. 3 by 3. And 2 by 2 also very less. So near to that. So 1, 0, 0. 0, 1, 0. What is this now? 0, 0, 1. And these elements are what next? 0, 0, 0. I hope you are understanding. So in this case, whether you are specifying n and m, they are going to be coming, but internally prepared what? Either n into n or m into m. Remaining elements above and below will become what? Other elements are 0. So see that here A and print it. Below elements are called what? 0. Here other elements are called what? 0. And the unit element identity matrix prepared or not? Clear or not clear? Clear. Let us go to, this is called n, m and all those things. Clear? Let us go to that. Students in the online, Ajay, clear? Huh? Respond, Ajay. Ajay, respond. Ajay. No problem, Ajay. Respond it. Is it clear? Ajay, are you okay? Okay. Coming to the point of it. Now I will go for what? A dot what? Endim. A dot endim. And next is called what? A dot what? Shape. A dot shape. But it is taking what? Equivalent matrix. A dot D type and all those things anyhow you have taken it. I hope you are understanding this discussion. Is it okay, students? Go to the description documentation part. I. ND array object is equal to numpy of I, n comma m, none, k is equal to 0 and D type. Here n represents number of rows. Here m represents number of columns. If we don't specify m, if we don't specify the m value, then n value will be considered as which value? M value. If we take m value explicitly, then it will form possible identity matrix n into m. And the remaining elements are filled with what? 0. 4 by 3, 3 by 4. Below zeros, last zeros. Filled with n by 1. Identity matrix, that 2. Possible identity. Closer possibility. Nearest, I can write. Nearest possible identity matrix. Remaining elements filled with 0. Here k represents what? Principal diagonal. If k is equal to 0 represents principal diagonal and it is by default. It is a default. If k is equal to -1, -2, so on, it is considered as what? Below principal diagonal. If k is equal to 1, 2, 3, etc., then it is considered as what? Above principal diagonal. Are you getting, students? Yes. Now you see np dot I of 3 by default 0.1 point like that. D type is equal to int. It is going to give you 1 0 0 0 1 0. D type I is equal to 3 comma 4. D type is int. I'm getting 3 comma 4. But see that this is only the square matrix. Other one is considered as 0. 4 comma 3 you see. This first, this up to here only identity. Other things are 0. 5 comma 6. 5 to 5 only identity. And the last one you see. All of them are containing what? Zeros. 6 comma 5 comma 6. D type is equal to printed like this. 5 comma 6 is equal to 2 minus 2. Minus 2 means this one is becoming what? Ones. Is equal to -3 and it is going to be ones. Last is equal to 1. K is equal to 1. This one. You see this matrices. 1. And if I just move something like this, of course, if I just move like this, you can understand. This is called k is equal to 1. K is equal to 2 means this part. This part is made as this. I is to 4. If I say out of its 8, all elements will become 0 only. And the last identity matrix, which is a very simple, it is a compact form of phi function is what? Identity. What the identity function says? NP dot. This function generates only square identity matrix. Square identity matrix always. ND array object and numpy dot identity n comma d type. What is n? Represents n by n identity matrix. There we have n and m. Here n is there, which is going to take what? N into n identity matrix. And it will be considered as both rows and columns. Let us go to that once and then check it out. A is equal to np dot identity of 4 I set 4. I am saying d type is equal to what? Int a I specified. It is a 4 by 4. If I say here 2, if I say 2 by 2 identity matrix. If I say 3, it is going to print what? 3 by 3 identity matrix. I hope you are following what I am discussing. Is it clear? Fine. So here there is no chance of taking, 3 comma 4 is equal to, that chance is not there. So identity got multiple values for this one. You have to take only one argument. So I will take it. If I say 4, only 4 by 4 identity matrix will be built. Understand? So print of what? A comma type of A, type of A. It is also, last is also called what? ND array object is created. Right, mom? So Rocky, I said 3 comma 4. It is not possible. Such a syntax is not available. You have to pass either 3 or 4. So this is straightforward identity matrix is built. This is comes under identity matrix generation. 4 by 4, 3 by 3, 2 by 2, like that. By default, it is a float. Identity matrix is purely building identity function, purely building identity matrix. So this is all comes under what? These are all comes under what? Creating an object of which one? ND array. Okay. Next, Monday class when I come back, Monday, tomorrow there is no class. Monday class when I come back, I'll tell you the mathematical operations on it. Next, statistical operations, I will go for it. Okay, na? So Monday, we'll go for mathematical operations. Statistical operations, I will explain. Standard deviation, variance, those kind of things will be coming. So this is something like a data types. Something like a data type. Fine? So if you go to a small mathematics program, if you want to do it, I can take it. Here I can say some program if you want to do it. Program for I function. What I will do? I will take it. Something like this. N is equal to int of input of enter what? Enter order of a matrix. Order of matrix. I'm going to take it. Now I will do what? A is equal to np dot I of what? N comma D type is equal to, I'm taking int. For example, int D type is equal to what I'm taking? Int. So int I'm going to take it. For example. And the print of what? A you say. Now I will say what here? Import. What is this now? NumPy as NP. And I will take it. I example dot py. So go to this place and save it into this place and try to save. Coming to this command prompt, cmd, and I hope so Python 4 p.m. cd numpy. So go to this py example. I hope it is saved in the desktop. Let me go to the save as into this place, in the same place, in this place, numpy. Try to save it. Execute now. It is asking something like this. 5 I am saying. 5 matrix is coming. Suppose 3 I am saying. Possibility of 3. If I say something like 5, you are going to get something like this matrix. Are you able to follow? You can build. If I say K is equal to, if you say here, order of the matrix, next I will say row. Enter rows of a matrix. Enter columns of a matrix. So here, n comma, what I am saying? M comma, and it is going to prepare what? Equivalent, possibility of equivalent matrix only will be built. And I already shown you, enter that 3. I am saying something like 2. It is going to print what? 6. 6 means what? 2 by 2 matrix only you can see. 1 0 0 1. You say, now 2 you say, 3 you say, you see 1 0 1 0 remaining elements are filled with this. Are you able to follow? So if I say 3 and 3, you will be getting perfectly 3 by 3 matrix like this. So this is a way. And already we know how to deal with the programming. Whatever the things we explain, you can write a simple way like this. Okay, simple. So Monday class, I'll go for what? Mathematical operations, statistical operations, I will explain. Okay, don't miss it on the class. Right, tomorrow there is no class. Monday we will follow. So one by one is possible.